Hello, welcome to PASS Summit 2020. My name is Grant Fritchey. Let's go ahead and get started. Today we're going to be talking about how to automate deployments for your database using the developer tools in AWS. Now before we get going, we do need to make sure that you know that you need to make sure that you're exploring everything that PASS has to offer. There are local groups around the world that you can visit. Although probably virtual right now. There's also the SQL Saturday events going on still, even though they've gone virtual as well. And then, of course, there's all of the exclusive PASS content if you're a PASS Pro member, the PASS Marathon, the PASS virtual groups, and, of course, there's a lot of volunteer opportunities. If you want to help move the community forward, you can. Now, your feedback is important, so please make sure to fill out that feedback form and take some time, let us know how we're doing. As I already said, my name is Grant Fritchey. I work for Redgate Software. I'm a DevOps advocate there. I'm also a Microsoft MVP, and I'm an AWS community builder. This is my contact information. If you want to get in touch with me after today, please do. I live on questions, so anything that you want to ask me, I'm here to try to answer if I can. So feel free, fill out the forms, use the information, and let's talk. Now, today, what we're going to cover, I want to show you what's available for DevOps in AWS. And so we're going to run through some of the different stuff. And we're going to build out a continuous integration process. Nice, simple, nothing crazy. And we're going to show how you can do database deployments with these. And it does involve some extra tooling. You will have to go outside of your AWS to do this, but you know there's a whole bunch of different tools, and we'll discuss them. And we're going to play with different databases. Today we're going to look at Postgres, but you could do the same thing with SQL Server, with any of the other RDS databases that are on AWS. It kind of doesn't matter. Any one of these can be done the same way. But let's kind of level set and talk about what we're talking about. Now, the thing is that we don't have to do DevOps. DevOps isn't anything fundamental. There doesn't need to be someone in your company with a DevOps, title. DevOps style is enough. And the idea of an agile culture, one that can move quickly, one that responds to change, one that drives change, that better supports collaboration. Hey, yeah, that sounds like great. Let's do that. Maybe working together would be a good idea. Between people, using automation and tooling in support of process. Now, that's what DevOps is. You don't have to do DevOps. You can just simply do a DevOps style. You don't, just the idea of automation in support of process, the idea of people in support of process, and process in support of people, frankly, is pretty fundamental. And that's really what we're talking about when we talk about DevOps. So don't get hung on this idea. It is all about, just ensuring that we've got a methodology of collaboration that allows us to do more and better automation to help everyone out. That's it. It's just all about the people. Now, if we are going to talk about DevOps, and let's talk about it just a little bit, the concepts are simple. Communication is everything. It's fundamental to DevOps. It's fundamental, frankly, to getting development done. If you're not communicating well, you're going to have a hard time delivering good code. And it's just that simple. The less communication you have, the more difficult your time doing this stuff is going to be. Now, we are going to have to put our code into source control. And databases are code. Never, ever let anyone tell you any different. Databases are code, and therefore databases should be treated like code, meaning they go into source control. Based on surveys done by my company Redgate, we know that only about 51 to 55% of you are putting your databases in source control in whole or in part. So that means probably not a majority of people, a minority of people are putting their entire database code set into source control. And it's fundamental to getting automation, you need to have a known state, and that known state is source control. So we need to be able to do that. Next, we have to have a shift left mentality. Now, shift left is hard, and I'm going to explain what it is in just a second. The idea of it is you're going to make your non-production environments look as much like production as you can. Now, a lot of people hear non-production looks like production, and they go, oh my God, I've got 50 terabytes of storage, and I can't possibly do that in my non-production environments. I'm done. The key is as you can. If you cannot have a 50 terabyte database in your non-production environment, don't. It's that simple. But as much as you can, make your non-production environments look like production. And the reason for this is that having non-production environments look like production, resemble production, you get a more accurate set of tests in your non-production environments. And so as you're developing and getting ready to release your code through your automated processes, you are testing on stuff that resembles production as much as you can get it. Because the more testing you do, the better off you are. And it's that simple. Also, we're going to automate everything we can. We're going to automate our testing as much as possible, and we're going to automate our deployments as much as possible. Can you do everything? Probably not. Can you always automate all your testing? Probably not. But you've got to have all that stuff in place in order to be able to deliver it. And finally, we're going to be monitoring. We're going to be monitoring our non-production environments. We're monitoring our production environments, because a big part of DevOps is ensuring that the stuff you do doesn't hurt. And therefore, you need to be able to see how things are behaving now so you can see how things behave after you make changes. So that's it. And so if we think about DevOps and the DevOps fundamentals and how that affects databases, the idea is all that communication means that we have one team. It's no longer the idea of on the one side there's this developers, and on the other side there's these DBAs. That's crazy. It's that has to go away. It's a single team, right? It's one team, one goal in mind: deliver functionality for our business, for our organization, whatever it might be. The beauty of moving your code into source control is that acts as a backup. And DBAs are all about backups. So having an extra backup, more backups of your code is a great thing. So it's a way of protecting your database better. Also, little trick, source control acts as an undo button. So it's absolutely worth your time to look into source control as a mechanism for controlling what you do. Shift left, the idea of shift left and making your non-production environments look more like production adds protection. Because as we're automating our tests, as we're automating our deployments, we're doing it on something that resembles production as much as we can make it. And therefore, it's adding protection to our production environment because we're failing in non-production to ensure that we succeed in production. We're going to automate our testing because that automates the protection. By automating tests, ensuring that we can run them over and over again as needed, it helps us to ensure that we've got an automated protection. All of this leads to practicing our deployments, running scripts before we get to production, knowing that that script will work when we hit production because we've practiced. Lots and lots of practice means that we get better at what we do. That's just a fundamental of life, really. And then finally, of course, monitoring. Monitoring helps. So this is how the DevOps fundamentals fold into the database fundamentals. And again, don't get hung on DevOps. You don't have to do DevOps. You simply have to have the ability to do DevOps style work. Automation, cooperation, communication, all of it in support of the process. And that's really all we're talking about. So when we talk about this stuff, one of the things that we are going to get into, all this gets very touchy-feely, right, initially, but ultimately it lands in a technical sphere. And so let's talk about some of the technology that we need. And so there are 4 fundamental tools that make up the developer tools of AWS. And the Amazon Web Services have these 4 tools: code commit, code pipeline, code build, and code deploy. Now, we're only going to look at 3 of them today, but we'll talk about all of them. The 3 that we're going to look at is code commit, code pipeline, and code build. So let's go ahead and get started talking about what each one of these are. Now, code commit is your source control. This is where your code goes. And it's a shared source control system because it's out on the cloud, but it is basically Git. It fundamentally is Git, and because it's Git, it means that you will have a source control system locally on your machine. Therefore, you can make versions, create branches, all that stuff locally with your code, and therefore have that local backup and that local copy of the code as you're working on stuff. And then you're going to deploy to the production environments or other environments, but that code will then go up into the cloud. So it's stored in a shared environment that more than one developer can get access to. That's the whole idea. Source control, again, it's the core of the process, because as long as you've got your code driving your deployments, you can automate all of this. If the code is not driving the deployments, automating it becomes very difficult, because if the code has to be manually manipulated at some point, or manually put together at some point, plucked out of the air or plucked from a database, or from scripts on your laptop, as you do that kind of work, it makes it harder and harder to automate. But if you're working only from your source control system, then you can actually automate things. So this is the start of our process, and it's what we have to do. Now, Git is one of the most popular ones. There's several sessions this week at Summit talking about Git and how to use source control. I strongly recommend you track down one of them and find out what's going on with that stuff. But Git is just source control, and the idea is that it lets you branch, it lets you version your code, it lets you mark it so that you know what you've done, and you can put your database code with your application code. Now, there's debate over whether or not you should put those 2 together. Some teams like it. I prefer it if I can. They are stored separately, right? Database is here and application is here, but if possible, I want them together in the same repository, so that when we version our code or when we branch our code, it branches and versions together. So, version 1.1 of the database is version 1.1 of the app code. And that way we always know that we've got the right stuff deployed. We always know where we're at within our support cycle and everything else. And it just acts as a communication mechanism, documentation, and a whole bunch of other stuff. But the whole idea here is that because code commit is out there on the cloud in the AWS, it gives us a central location where we can access our code. That makes it easier for the teams to share, and it makes it easier for us to automate. And that's what we'll be doing later, is automating it. Well, how do we automate it? That's the question. Well, the answer is pretty simple. We're going to use the code pipeline tool. Now, the code pipeline tool almost explains itself. It is the ability to build a series of steps, 1, 20, 1,000, whatever, however complex your system needs to be to support your deployments. You make it there. I mean, it's just, we're going to only use a couple of steps ourselves today as we walk through this. But the idea is that the code pipeline defines triggers. And so you have some triggers that fire. Now, by trigger, what do I mean? Well, this is where things get fun. We can work with our source control system. And so, for example, what I'm going to show today is that when we commit code up to the main branch in source control, that update to the main branch will then fire this stuff. It acts as a trigger. So that's one mechanism. But you could schedule it, you could make it manual, you can have it do builds based on other builds. So like if the application code is successfully built, then do a database code test. And then obviously vice versa. If the database is successful, then do an application test. You'll figure out what it is you need to do, but you can set all these triggers up. And then the code pipeline controls the flow. It allows for decision points, it allows for actions, and you can take direct control over how everything is done through the pipeline process. And we'll see it as we walk through it. It is the first step for setting up continuous integration after you've got your code into source control. This is the first step for the automation. But you have to get your code into source control to begin with. And then you'll be using the code pipeline to feed from that code commit and then start doing builds. Speaking of builds, let's talk about code build. Now, code build is where all the action occurs. Code pipeline makes the decisions. Code pipeline does, triggering, and it can call a whole bunch of different things. But code build is fundamentally where the action is. This is where the hard work begins. Now, what is it doing? Well, first off, it's going to be using this thing called YAML, and it uses build spec. It's a buildspec.yaml file. That's it. It's just off it goes. You put some code into that build spec file, and you're good to go. Well, wait, what? What do you mean? What's going on? Well, what's going on actually is code build is taking advantage of the ability to spin up a virtual machine. And so what it's going to do is it's going to spin up a virtual machine, and you can define exactly how you want that virtual machine to look. And as we walk through the demos today, we will see that in action. But it spins up a virtual machine and then allows you to control what happens after that virtual machine is built. And so that's where you can start to put code to work. You can start to automate your processes. And that's what we're going to do today. We're going to automate a continuous integration process, and we're going to do database builds through our continuous integration. And so that's how it works. Now, it's just command line stuff. There's nothing that special. It's scripting, and it's all about just scripting. And you can kind of pick the command language that you'd like to use, but it's just on you. However you want to call different commands. And if you're on a Linux system and you want to use Bash, you can do that. It's just all down to how you would like to control it. It's going to run from the build spec file, but there's a whole bunch of things it can do. And we're going to walk through all of that in a lot more detail when we get to the demos. Finally, it generates artifacts, and that's the big deal. And what do we mean when we say it generates artifacts? Well, if it was code, it's creating an executable, and then that executable can be distributed around and whatever. But in our case, we're talking about databases. So what do we mean when we say an artifact with a database? SQL code, right? If we're talking Postgres, it's SQL code. If we're talking SQL Server, it'd be T-SQL. If we were talking Oracle, because you could do the same thing with Oracle, it'd be PL/SQL. But it's just our code that we're going to use to deploy, and it's that simple. Now the deployment, that's what happens next. The code deploy process is what's dealing with multiple environments, multiple places to run this code. If we say have 3 production databases that we need to deploy to, this is what's going to handle picking up that artifact, that PL/SQL that we just created, or that the Postgres SQL, whatever it is. In our case today, it will be Postgres. But taking that code that we've just created and then moving it to each of the different environments. Therefore, this is what deals with security. This is what deals with the platforms and the ability to move things around and ensure that the deployments are done correctly. That's what code deploy is all about. So basically, we're taking code commit, putting our code in source control. Once it's in source control, the pipeline can take over and control things, and the pipeline will call build or deploy as needed in the right order and make those things happen. And that's it. Code commit to code pipeline using build and deploy to make all this stuff occur. Nice and simple. It's actually very, very simple. not really. It's actually a lot of work to get set up. It's not that easy. But also, here's one thing: we need a little bit of magic. It's just unavoidable. The fact is that databases are not code. It's the simplest way to put it. They're not the same as code. The objects inside databases are code, right? And that's why we're able to use source control, and that's why we want to use source control, because what defines our database is code. But the database is data, right? It's the information contained in there that matters. And the issue is that you cannot deploy around the data the same way we deploy applications. Applications deploy by replacing what was there before. We can't do that because we have to keep the data. The data persistence requires us to bring in a little bit of magic. And there's a whole bunch of different tools that you can use. From Idera, DBUp, Microsoft SQL Server database tools if you're just working within SQL Server only. Redgate Deploy, great tool, if I do say so myself. Datical, Flyway, DB Maestro. There's probably a few others I've missed. Most of these tools don't work exactly the same way, but they all have the same idea. And the idea being databases require some extra work, and we're going to give you that little bit of magic to make it happen. Now, the demos today, we're going to use Flyway. It's an open source tool. You can take advantage of that fact. And it's also very, very cross-platform and supports a huge number of different databases. So that's why I'm using it. If we were trying to do this, say, with Microsoft SQL Server database tools, we would have to install those onto a virtual machine after we built it up. Or we would have to create a virtual machine that we keep on the side and then, that has this installed, and then we spin that up as we do for our code build process. So the different tools are going to work in different ways. Now, Flyway works with containers. So because it works with containers, I can easily spin up a container on the virtual machine that I'm creating through code build and then fire commands at that to make sure it does what I want it to do. That's all I'm doing there. So it's a one way of doing it. So maybe you could build containers for these others as well. Most of them I don't think support containers out of the box, but you probably could build out a container for supporting them. Although you will have to build, like in the case of Microsoft SQL Server database tools, you would have to build a Windows container, which not as easy as building Linux containers, I gotta say. But anyway, you will have to plug this in to the process. And so the code build will probably call one of these tools in order to generate an artifact. And that's what we'll do today. We'll use the code build to generate one artifact, a SQL script, and that will be how we run things today. Is using the Flyway tool. But you could also need to use one of these tools in your in your deploy process as well. It's just all down to what's necessary for your deployment. But you are going to have to get one of these for supporting the database deployment, just because of data persistence. You've got to protect the data. You cannot simply replace the database. If we could just do that, this would be easy. But it's not, and so it's more difficult, and therefore that's why you would pick up one of these tools. Okay, well, that pretty much sums up what we're going to do. I think we should go do it. So it's demo time. Let's go take care of that. So let's start with, we're in Postgres, and I'm using Azure Data Studio here. And what we're going to do is we're going to create a new table. Now, I'm not going to run this. What we need to do is save it. So let's do a file, save as. Let's make sure we're in the right folder, and then we give it the right format. There we go. There we go, all saved. Now that's going to update our source control system. So if we take a look, we've got that saved there. Okay, cool. Let's take a look at our source control. And what we should see is that we've added this new file. So we've added this file here locally, and this is my local source control system. This is my local Git repository, and so I've got this new file. Let's go ahead and stage it, and then commit the changes. So we've got this local change that we're making, this new table. It's the script's happy. We're good with it. So we're going to commit it to our local repository. And anytime you're doing a commit, of course, you definitely want to make sure that you put comments in. So we're going to say creating new table for Pass Summit. And so we commit that to our local repository again. Now, the whole idea here, though, is that we're using AWS. And so what we're going to do now is push the changes that I've made up to my source control system in AWS. So let's go take a look at that. Now, this is my repository in AWS. It's the Ham Shack Radio data repository. We can open it up, and it's going to show us the files. And if we take a look at the SQL folder, there, sure enough, is the version 5 thing that we had added. Let's go ahead and zoom in a little bit so you can see it there. There you go. So we've added that file, and it's part of our system now. So we've got, we've checked that in and added it. And then this is the source control system, and you can see the commits that have occurred over time. So you can see all the changes that we've been making, all the days and stuff that I've been testing it out, making sure we're getting ready to demo it for you. I've got a lot of different changes that have gone in. I haven't messed with the branches a whole lot, so we've only got the single branch right now. It does have changes that have been made to it, and so it's good to go. And that is code commit, and that's basically code commit and what it's doing. So you saw that what we did was we took our local file and we checked into source control. Nice, simple, straightforward. Then we took that and we pushed it up to AWS, and AWS took control of it and is now holding that code for me in the code commit location in AWS. So that's great. Now, the next tool that we want to take a look at is the pipeline tool. Now, I've got one pipeline right here. Let's go ahead and take a look. Here it is, and it has 2 whole steps to it. It's a very small pipeline, but this is how we would start the process. So if you've got your code and source control, as we've already done here, that's great. But the next thing you're going to want to do is you want to build a pipeline. Now, the pipeline has got 2 steps. First, it's going to source control, and it's going to get stuff from source control. The source control it's going to is my source control system. Now, we're going to take a look at it, and we're going to edit this process so we can see what's going on. And then we'll edit this stage. And what's going on within this stage specifically is that we've got to go to source control, the action provider, and there's a whole bunch of different action providers. You've got testing that you can do, including with Jenkins, with Code Build. You can work with GitHub, Bitbucket, wherever you want to put this stuff. You've got the ability to do invoke, so you've got AWS Lambda to make calls there. You've got the ability to make deploy calls through code deploy, cloud formation, all these various things, build steps and approval steps. And so yes, and you can put manual approval steps into your pipelines. So your pipelines can do whatever it is that you need done. So you can actually have it pause, wait for you to approve a given change, and then go forward from there. But in our case, what we're doing is this is source control. We're going to the Ham Shack Radio source control. Now we could remove that. If I hit the X here, it'll go away, and then it's going to go and look and see what repositories do I have. Well, the fact is I've only got the one, so it went and tracked that down. We could also remove the branch, but it's going to go and look for the branches and determine which one we have. In this case, master. So awesome. We can determine how we want it to do the trigger, and then we can give it variable namespaces and output artifacts as needed. We're going to hit cancel. We don't want to make these changes right now. The next stage is a build stage. You guys already saw that. So if we take a look and edit the stage, we can see that it's a build, and we could modify that as well. And then it's going to show us what's going on within that build step. Now we'll get into the details of the build step here in a minute. but the basic actions are the same way. Once again, you're going to look at it and say, okay, well, what's going on? Well, first, it is a build step. It is using AWS code build. It is not using Jenkins, although you could. You want to make sure that you're running within the right region. If you put it in different regions, you're going to have problems. So best to put it all in single region so you're controlling it the way you need to control it. Yes, you can hop regions. Heck, you can even hop accounts if you need to. There's all kinds of things that you could do. Generally, especially for something like a CI process, I would keep it all within a single region. It's going to cost less. It's going to run faster. And for a CI process, you want it to run fast, right? Continuous integration should be a quick step. You're going to have to give it a project name, which is great. We've already got the one project in existence. If you need to add in variables, you can. We don't have any that we need. We're doing a single build. We could do multiple stuff. We could do all kinds of batches and put it together, but none of that is necessary. And so that's just the definition of the pipeline. So the pipeline, when it runs, will go and get the source control from my source control system, and then it will fire off a build. So we can actually do that. We can make it happen. The code commit would normally do it, but we can also cause it, release the change from here. We're not going to do anything just yet because I want to show you what code build is doing. Now the code build process we have is right here. Now I've run it a whole bunch of times, again, prepping for what's going on, but let's edit the actual build process. So you can see that we have to set up a configuration. I do recommend, if you can, using tags. I've tagged everything as Ham Shack Radio. It makes it easier to find things if you tag your systems. So I've got that done. Let's look at the other processes. Now, if we take a look at the source, you can see that it's where is it coming from? Well, it's coming from the code pipeline, of course, and then we know we can specifically look for a given branch or whatever, but we're not going to do any of that right now, and we're letting AWS modify it. Now, if we go back here another step and then edit the environment. So what's going on is I'm going in and I'm getting the AWS code build standard, just the regular stuff, nothing fancy. You can see that. I'm letting it build out from a particular service role, and then in terms of what it is I need, it'll queue. If it needs certificates, it'll get them, but otherwise it won't. And by and large, I'm able to use my local subnets and all my configuration, and I can control how big the machine is. It's the smallest possible machine because it's just not doing much. So I don't want it to run a whole lot and cost me money. So I'm keeping it all under control the way I set it up. Now we could, let's discard our changes. Now we could go in here and say, let's take a look at build projects, and we can create a build project so you can get an idea of how all of this looks together. So we'll call this one Pass Summit. We would add a description, we would add a tag. The source is, where is it coming from? It can be code commit, whatever. Again, we're gonna go with the same idea. We'll go from code commit and our Ham Shack Radio. We can do it on branches, and we'll go ahead and do from the main branch. Cool, nice and easy. Now, the environment definition. Do we want a managed instance or do we want a custom instance? And you can do a custom instance. I'm just going to do a managed instance in my case, and this is where again you're going to pick the operating system. I prefer Ubuntu. I'm just more familiar with it, but the other Linux system is fine. I'm going to go with standard runtime, and you can pick what image you want. I'm going to go with the latest one. It's always going to do the latest one, and then we know it's either Linux or Linux GPU. We can determine whether or not it needs to be privileged. It does not need to be for my cases. We can create new service roles, and we can set up security as needed. It's all the way we want to. We can insert build commands directly from here, or we can use a build spec file. I am using a build spec file, and we'll get to what that is in a minute. the batch configuration, if you want to run more than one batch, and then you can determine what's going on with artifacts. If you're doing artifacts, the method is going to be to store them in Amazon S3. You're going to put them out there in storage, and then once they're in storage, you're going to be able to do things with it from there. So that's the trick, is that you can go there and take a look at it. Cool. Now that's if we were going to build one. We're not going to actually build one right now. And then you can also set up logs, and you can set up alerting. Mine is alerting when a successful build is completed. I get an email letting me know that it was successful. If it fails, I get an email letting me know that it failed. So now, what does the build spec actually look like? Well, let's go take a look at that. Now, I'm using Visual Studio Code for editing my stuff, and this is a build spec file. And if you think that there's not much to it, well, there doesn't have to be. It really depends on what it is that you're doing. Now, let's just take a look at it. Make it just a little bit bigger. There we go. So you have to determine the version, fine. There's a whole bunch of things you can put in here, but I mainly wanted to focus just on the phases that are available to you. There's a whole bunch of extra things you can do. Input variables, environment variables, certainly the artifact generation, you can make more controls from it through here. But basically, I'm going to focus in on the phases, and we're going to talk about what those are. Now, phase one would be an install phase, because what this is doing is this is spinning up your VM. So you've got a virtual machine running. What do you want on it? Or do you need anything extra on it? Now, that virtual machine is going to have a bunch of stuff. It's the standard build machine from AWS. You can go and look up what that is and what it has. The main thing I need from it is it has Docker, because I'm using Docker containers to take control of my process. But if you needed to do installs onto your system, you could. If you needed to do pre-builds, you could. If you had some extra steps you needed to set up prior to running your build process, anything from security to data movement to anything along those lines, if you need extra steps, you can put them in. Then you run the build commands. We'll talk about what that is in a little bit. And then you can run post-build commands. So if you wanted to add additional testing, you could put additional commands right in there in the post-build commands. So the build process runs, it generates your artifact, and then you can run extra steps if you wanted to, right? It's all down to what it is that you want to do or need to do for the processes that you're managing. But because it just runs, right? I mean, it's all going to go. Now, Docker run in this case is the command I'm going to send, and you'll see I've got a number of different commands I've sent there, and they all look the same because each one of them is, if I call it, depending on which one I call, is spinning up a container to then just run the command. If I had a series of commands I was running, I would only spin up the container once, and then I would call, and then I would issue commands to the container, not have to run it over and over again. You would just issue the commands to it. This isn't a container class. We're not going to get deep into the container stuff right now. But the basic idea here is that I just have to issue a command to Flyway. So that's what I'm doing, is I'm saying Flyway, which is the way that you issue the command to the container, telling it that I'm an enterprise version, and telling it to run the migrate process. And the migrate process is is that magic bit. If you remember, I said we need a magic tool to make that magic connection. This is the bit of magic that has to happen. It's unavoidable. You have to show it off. It has to be done. There's no getting around it. So, just plan to have that in there. Right. Let's take a look at deploy. So if we take a look at it, it's right here. Now, we don't have any deploy steps because in the CI process that we're running, we're just doing the build against a database, a Postgres database, right from the build spec file. We could have it generate an artifact. You could put other steps in there, but right now that's all it's doing is just running it directly from the build spec file, so I don't need to do deployments. But if you wanted to, you could add deployments in here, and there's a whole slew of things they can do. And it's all about hopping between the environments and dealing with the fact of various environments that you have to work with. That's what deploy does. So that's where it goes. Now, having walked through it, we're going from our source control system, and it's doing its work. Code pipeline is controlling the stuff, and doing the things in order. Build is running the commands that we've defined it within this build spec.yaml file. All right, so that's everything that's going on. Cool. Let's see it in action. Let's actually see it run. So what I'm going to do is I'm going to actually go back to the pipeline, and I'm just going to tell it to release a change. So now what it's going to do is it's going to go to source control. It's going to go to source control. It's going to pull anything out and find if there's been any changes to source control. Now we know there have been because we added that file that creates a table. So while this is running, let's just run back over here and take a look at one thing real quick. If you'll notice, there is no person table in our Hamshack radio database. So that's not there right now. Let's go back over to here. There we go. Now it's completed the source control and it started the build process. So let's take a look at what it's doing in the build process because we can actually see it run. I haven't been showing that to you because I didn't want to save it until now. It's running, it's in progress. Well, let's take a look at the details. So we can go in here and we can see what's going on. Now it's going to show you a whole log of stuff. It hasn't come up yet because it's still building out the VM is what's going on. Well, once the VM is done, there we go. We can see it. It's starting the process. We can see, let's zoom in, that it's spotted the build spec.yaml file. Okay, cool. Now it knows what's going on. It's moving to the directory. It's registering the agent. It's found one phase in there. It's a build command that we've added. So it's done that. It's gone and downloaded the source control. You can see that step right there. If there was an install step, if there was a pre-build step, each one of those is succeeding because there's nothing there. And then the build step starts. Now the build step is running the command that we told it to run, the Docker command. It's pulling the image, right? So it's pulling it down. It's verifying that it pulled it down. It's getting it down here. And so now we have a Docker image running locally with Flyway on it. Then it's running the command that we told it to run. It's running against an AWS Postgres file, Postgres database, sorry. It's validating the migrations. It's recognizing that the current version is 4.1, but we've added a new version with version 5. So it's migrating the schema public to version 5.0 by adding a person table. Excellent. It's successfully applied that. It's succeeded, so it closes down. That's the entire process. You can take a look and see the phase details. So you can take a look here and you can use this to troubleshoot when things go wrong. I've had to do that before. It gives you a lot of detail in here so you can really understand what's happening, how long each thing takes. You can see that in this particular CI process that we're running, the actual longest process, start of the process, is provisioning the server so we can run this on the fly. Now, could you have a server provisioned all the time and not have to do that step? Sure, but you're going to pay for that, quite a lot of money. So better to spin it up when you need it, use it while you need it, and then throw it away again. But that took 42 seconds. It took 11 seconds to do the build step, but that includes downloading the image from AWS, because it's all up on AWS, of the Docker file. So I've downloaded that Docker file image and when I did the run command, and then it did the build. Well, the actual build step within that is trivial. I mean, it's a very short period of time. I think we can even see it on the timing. Yes, there it is, execution time. 0.079 seconds. So that's probably one of the shortest part of the entire process. Well, and then the 0.056. So we're up to zero point 0.1 seconds for this part of the process to run. So I'm not really sweating that. Obviously, if you want to spit out reports, you can. You can control things through the environment variables, and you can see the build details. So it shows you where it came from, the commands issued, the service role, how the VPC was used, artifacts, logs, everything that is recorded. And you can even see resource utilization over the process. Now, I haven't done this because I'm not leaving it on because I don't care. The image is gone, there's nothing there, so I don't need to sweat it. But I could watch it in real time. If it was taking longer to do the builds than the 10 seconds that it takes, we could actually see it in real time. But you know what? Let's go back over here now and take a look at let's refresh our databases, take a look at this. And if you look now, we do have a person table. So this is our AWS RDS Postgres database, and it now has the person table that we created the script for. And so what you've seen is that we've created a script. We took the script and checked it into source control locally, right? Remember again, we went through local source control. Oops. We went through local source control here, made the change, committed it locally, pushed it up, ran the pipeline. Let's go take a look at the pipeline. Ran the pipeline. The pipeline did its 2 steps, running the build. The build did its step, which is calling the build spec.yaml file, and then finding out what commands it has to run from there. And then those commands run, and you see the output here. And so that gives you a complete overview of everything that occurs within these processes. So that's it in a nutshell. Now, if that seems complicated, that's probably because it is. There's just a lot going on here. There's so many different tools that you need to have at least a working knowledge of to be able to put this stuff together. You have to be able to get your stuff in and out of source control, and that's why I recommend starting there, because it's the foundation for everything that you're going to do, and 2, it's the first thing you ought to learn. It's just going to be easier to learn source control than trying to not know source control and then consume source control by learning all this other stuff. Obviously, once you've got the source control down, the next thing you need is to be able to do this, right? To make these commands, whatever they are. In my case, run this flyaway container. But if you were using one of the other magic tools, you would then, whatever command line you need to do to get that magic tool to run, to get the database changes generated, that's one you need to learn. Once you've got that down, then you start learning this stuff, and you go to Amazon and you take a look at the developer tools. Excuse me. Which are, again, code commit, which is your stuff, code build, and code pipeline and code deploy. Pipelines are really the easiest part of the process. You're going to create these things and run them up. It's the build steps that are the harder things, is setting up these builds, understanding how to control the YAML file, understanding how to control the VMs that it's going to create, and all the necessary stuff around that. That's all more of the work than anything else. And then once you get to deploy, that's how you start hopping across environments and making changes. You can even use deploy to deploy from AWS down to your local system. So you don't have to have everything up in the cloud. You can use the developer tools here from AWS to deploy to your local systems, to your local databases, if you want to. Again, it's just a question of setting up the configuration, setting up the security correctly, because once you've got the security set, then you can build out all the stuff as needed. Let's see, did we show enough tools? We used Azure Data Studio, we used Visual Studio Code, and then we used the AWS console along with code deploy, code build, code pipeline, and code commit. Oh, and by the way, Git locally. So not sure how many tools that is, but there's a lot of stuff. Like I said, there's a lot of moving parts to this. And that's about it. So let's start wrapping things up, shall we? Right, that was our demo. Now, I want to recap it again, just because there's just so much involved here. So let's walk through. Now, we're starting from a Postgres database. We have a Postgres database. We have data. We want to secure it, but we're going to make changes. So the first thing I'm going to do in this case is open up Azure Data Studio to write my T-SQL script, or not T-SQL, to write my Postgres SQL script, the SQL I need to be able to make the changes to my database. So that's, the tool I was using to modify the SQL. From there, I was able to add it to my local Git repository. Git is code management, it's source control, but it's multi-stage, so you can control it locally as well as in a centralized location. Now, locally, I've got versions, branches, all that fun stuff, and I've got it all controlled so I can do undos, I can validate it before, I can test it and validate everything before I push it up to my centralized location. Once I'm happy with the code, I do push it up to my centralized location. In this case, I was using AWS Code Commit because it's all part of the AWS DevOps tools for the developer tools. It is effectively, to all intents and purposes, just Git, but it's up on AWS, so it's controlled through there. But otherwise, it's all the other things that I would do with Git and source control, branching and all the rest, merging branches. All of it can be controlled up there in the AWS cloud. That is going to kick off the pipeline process. Now, the AWS pipeline is the flow control, right? That's why they call them pipelines. It's all about flow control, what gets deployed where, so it's pulling from the code commit, obviously. But in this case, I used Visual Studio Code to write my buildspec.yaml file, which also has to get added to your source control. It's all part of the same process. Everything's in there, and so that's then added into that, which kicks off the AWS build, code build. Now, the code build runs the commands that I've defined within the buildspec.yaml file that I wrote in Visual Studio Code that is being called from the pipeline that's stored in my AWS source control system. Yes, this is complicated. Now, the commands specifically that it's running on the virtual machine, that AWS code commit, was to create a Docker file. I'm sorry, not a Docker file, a Docker image, to create this Docker container and run it. And then from that Docker container, it sent the container it created was a Flyway container, and so the commands were issued to Flyway to build a database. That went through the deploy process, and then it all landed back in my Postgres SQL database. And that's the goal, was to deploy through an automated fashion to my Postgres SQL database. And yeah, that's all the steps and tools involved. One end to the other, all the way through the process. This is what was done. And so, yeah, there's just a lot of moving parts. No one thing here is hard. It's combining them all is the challenge. It's the fact that you have to combine them all. There's just not an easy way to get around. Can you skip using a local Git repository? Well, not really. If you're developing code on your local laptop, you've got to have that locally. Do you have to use Azure Data Studio? No, you could use something else. It's the tool I chose to use. Do you have to use Visual Studio Code? No, you can create your buildspec.yaml file in a notepad or any other editor. It doesn't matter. Do you have to use Docker containers? No. Again, it makes it easier for me to create that Docker container, that flyaway Docker container, just because it's simple. I don't have to do an install. I don't have to move files around. I can issue a command and I get exactly what I need the way I need it. Do you have to use Flyway? Of course not. It's the magic bit I used here, but there are other tools available. If you're doing SQL Server only, you could do Microsoft SQL Server data tools, DB Maestro, DB Up. There's a lot of choices in there. It's just all depends on what you're going to do. Then the deploy handles the cross server instances and consumes the artifacts created in the earlier processes, and off we go. And that's the full-blown thing. Now, before we go, I want to make sure you get some knowledge. There's some additional places, some additional information you can get. Now, the Building a Continuous Deployment Pipeline is an AWS blog post, and it gives you a lot more detail than some of the stuff I've given here. It's a much more sophisticated project, and I wanted to keep mine very simple. As you saw, there was a lot of moving parts, a lot to understand, a lot to unpack in a simple project. This gets to a very complex project, so there's a lot of information there, very useful. Track that down. If you're just getting going in DevOps and DevOps style stuff, I strongly recommend you read the Phoenix Project. It is not a great book. It's a novel about IT, which is really a strange sentence to say, but it's not a great novel, but it's a fantastic parable of what DevOps is supposed to be and how DevOps is supposed to help you. And again, don't get hung on the term DevOps, a DevOps style approach, right? It's all about communication and automation to support people and processes. I also recommend Introduction to Database DevOps by Robert Sheldon. It's a series of articles. And then if you are interested in Flyway, there's the Flyway documentation is also there. Now, let me just wrap up with one last thing, and that's start with source control. This is your key. Start with source control. Get your databases into source control. Get the whole database in source control, not just bits and pieces, the whole thing. Practice your command line stuff. Learn your command line. Whatever you're doing, however you're doing it, Bash, PowerShell, whatever it is, learn the command line stuff so that you can use it to build out these processes. Start with a CI process. Keep it simple. And yes, that CI process was simple. Everything gets more complicated after that. But start there, get that done. If you can build that CI process in an automated fashion through the command line from source control, then you can get into all of the expansive stuff, all of the rest of the things that are going to have to be done. There's so much more there. You'll have to deal with it. Not a whole lot else I can say, but just start simple. Source control, the command line, and then a CI process. Get those three, and then the rest will come with time. That's it. That's all I have. Thank you very much. I really hope you're enjoying the past Summit Virtual 2020. And this is, again, my contact information if you'd like to get in touch with me after today. What we're going to do now, though, is go to a live session to answer any questions that you have outstanding after my session today. Thanks a lot. Have a good day. Bye-bye.